All right, friends, here we go. Number one. Jackson's already got it done. Get your feet on the floor. Are the following permutations or combinations set up and evaluate? Jake must choose 4 teammates with whom to shoot around. There are 10 men on the team. So is this going to be 10 P4 or 10 C4? C. It's just 10 guys or 4 guys to shoot with, right? It's not like he's not picking a, what are the things in basketball? He's not picking a forward and a center and a guard and whatever, right? He's just picking 4 guys to shoot around. So 10 C4. Everybody okay with that?
Yep.
On the quiz, you will of course write 10 C4, but then you will evaluate that.
Using your calc?
Yes, you have to use your calc. You write 10 C4, and what is 10 C4? 210. So 210 is the official answer. I want to see your setup though, because if I see your setup, it might be wrong, but I can at least give you credit for it perhaps. All right, Kamara is going to assign the following roles on CHS Live. Anchor, sportscaster, jokester. There are 12 students eligible. 12 P3, 12 C3. P, because they are getting specific jobs. Right? And 12 P3 is 1,320. Does everyone see the difference between A and B?
Yeah.
All right, here we go. Kara must tell Coach White that she can't play in 4 of the 21 games. So 21 C4, 21 P4. C4. We don't know which games, we shouldn't know it, we just can't play in 4 of them. She's only allowed to play in 17 games. So 21 C4. Beatrice is going to take 2 of her 7 siblings to the movie. 7 C2. Right? Meg is going to give her 4 sisters her favorite math possessions. Her calculator, her pencil, her binder, and her marker. 4P4. 4P4. She has 4 people. She's given something to every single one of them. Order matters. 4P4. 24. Evaluate 22C20 by hand and show all work. We talked about this yesterday, right? Did we talk about doing these by hand? How do we do 22C20 by hand? Let me check my notes. Oh, maybe we didn't talk about that. Oh, no, we did. We talked about that, guys. You don't remember?
Pascal's triangle.
Huh?
Pascal's triangle, right?
No. Now, I'm evaluating this by hand.
Is that like the rows?
Huh?
Like the pyramid thing?
No, that's what he said.
The pyramid scheme.
That number will show up in Pascal's triangle, but no. Okay, get your notes out and look at, it's the front of page 2, right at the bottom. Page 2 of your notes, right at the bottom. You were evaluating by hand, right? Do you remember? Bottom of page 2. No, how about this, the physical page,
This one. Or maybe 22 back.
right here. Oh, you were too busy drawing, so you didn't write it down. So Alden, what did you come up with?
22 factorial or 20 factorial.
22 minus 3.
And 2 factorial. So this is gonna have 22 factorial, that's that number. over this number and the subtraction of those two. Okay?
But then how do we do that?
Well, remember, how do
Oh,
we do
they
it by hand?
cancel, they cancel.
A whole bunch of stuff cancels out because we know 22 factorial means 22, 21, 20, dot, dot, dot.
Yeah.
What does 20 factorial mean? 20 dot, 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 won't all that cancel
Yes.
from 20 on down? So I have 22 times 21 on top, and then a 2 times 1 on the bottom. This guy's still left on the bottom. So 2 goes into 22 11 times, and now you can go to your calculator and do 11 times 21. And what do you get?
231.
2 what?
31.
231. Now, go ahead and type 22C20 and make sure you get 231. So that one problem, when I grade it, this is what I'll be looking for. I know you can type it in on your calculator. I know you can, and that's great, but you don't get points for that. You get points for this work right here. All right, if I have 8 flavors of cake, 10 flavors of icing, how many different graduation cakes could I make? Eight times 10. That's right, 8 times 10. Every cake can be matched up with an icing, right? So each cake can be done 10 different ways. There's 8 cakes, so 80. 8 times 10. When we went over that concept in class, I used jumpers and shirts as an example. If I have 8 jumpers and 10 shirts, don't I have 80 outfits? Yep. If I have 8 cakes and 10 frostings, I have 80 cakes. In how many ways can I arrange the letters of the word "you are my favorites"? What do I do? How do I even begin this problem? Well, first I have to do what? Count them up. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You get 17?
I sure did.
So I start with 17 factorial. And then, I know there's a lot up here. What do I have duplicates of?
Y.
I have a Y and a Y, so 2 Y's. I'll subtract that. I have an O and an O.
2 R's.
R and R.
2 E's.
2 A's.
A's, 1, 2. E's. Wow. Is that it? All right, let's type it in, make sure we all get the right answer. Oh my goodness. It's a lot. 1.111 times 10 to the 13th. See if that's what you got.
It has to do with divide by like.
Can you, when you're typing in, can you do 2 factorial for a fifth, or do you have to, like?
No, you can do that.
1.1.
Okay, am I missing anybody? Yeah, where's Charlie? He came late yesterday, as I recall.
He's here today, I literally saw that lunch.
Great.
We're in the home stretch. It's the fourth quarter, you can't get much.
You know, there's no home stretch. It doesn't matter what you need. You're good.
This is four and all that.
I'm keeping my X on that.
All right, you good? Everybody get this?
Yes.
We gotta be careful with these big numbers. You've gotta remember to put this on the end. If you just said 1.11, obviously that is not right. Right, so make sure you put that on the end. All right, find the third term of 2x minus y to the fifth.
This is what we try. 5, 4.
2x minus y to the fifth. Now, some of you, where do I want the third term? Some of you were talking about Pascal's triangle earlier. This would be a problem where if you wanted to, you could certainly use Pascal's triangle. You do not have to, we have another option. But if you're gonna do Pascal's triangle, you have 1, 1, 1, 2, 1. Remember how to build it, you start and end with 1 and then add.
Those are
So the fifth row is pretty quick to get. And the third number in the fifth row is that one. Now, how else could we get that number if we didn't want to build out the triangle?
5C3
This one, the first number is 5C5. This one would be 5C4. So Eli says 5C3. That'll work. That gives you 10. The important thing is you've got 10. Next to the 10, you have a 2x and a negative y. Right? The power on 2x would be 5 here, 4, 3. And if you put a 3 there, you're putting a 2 there because they have to add up to 5. And now we simplify, and this is where we have to be careful. This is not going to be 20. That's not 20. What is it?
A negative numbers.
It's not negative either. It's not 60. 80. Why is it 80 x cubed y squared? 2 cubed is 8. 2 cubed is 8. Why is it not negative? Because we're squaring the negative, right? That's getting squared. And when you square a negative, it becomes positive. So your answer is 80x cubed y squared. Is that okay with everyone?
I got that.
Well, you gotta get right tomorrow. That's what matters. All right, the 17th row of Pascal's triangle. Not writing it out. What would be the first number in the 17th row? 17C, 17? And the next one is 17C, 16, 15, I think it's 14.
14.
The fourth one would be right here, wouldn't it? So I just type that in on my calculator. And that number is 680. There are no office hours tomorrow because of a meeting, but there are office hours on Friday.
I wouldn't do that.
I early start. School starts on time tomorrow. Okay? Got it? Quiz on Friday over this. All right. Put that away. Let's get back to our notes. We're going to finish up 9.2 today. We're almost done, and certainly that homework is within reach. I am assigning that homework today, so it too will be due on Friday. Friday is a big day for us.
I don't think you can. So it's really bad. I don't think it's everybody. But we just do it.
All right, back to our notes. We did not finish problem 5. So let's refresh our memories, what's going on in problem 5. In problem 5, we have 10 questions, and each question has 4 options. So remember, if you are guessing A, B, C, D, you're guessing, you have a 1/4 probability of being right, and you have a 3/4 probability of being wrong, correct? Now, what do we want to have happen in our problem? Well, we want to get at least 1 correct. Now, wait a second, think about that for a second. How many questions are on this test? 10. Nope, we haven't done the last one. At least 1 correct. What does that mean? I could get 1 correct, or 2, or 3, oh my gosh, or all 10, right? I can do these as individual problems. So for example, let's say I want to do the 3 correct. There's no way to do all these together. They're done individually. So 3 correct would be 10C3, 1/4 to the 3rd, and 3/4 to the 7th. Now, there's a lot of talking and there needs to be focus. Where did 10C3 come from? I am just randomly doing 3 correct.
You're getting 3 correct, yeah.
10 questions, pick 3 of them to get right. C, no one cares which 3, just get 3 of them right. So 10C3. Now, 1/4 is the probability of being right, and I want 3 of those. 3/4 is the probability of not being right, and I need 7 of those because there's 10 questions altogether. Does that make sense to you? You could do the same thing for 4 correct, right? And 5 and 6. I mean, oh my gosh, that's a lot. But you could do it for each one of those, and then you would add them all up. Because you're getting 1 or 2 or 3 or 4 and so on. Yesterday we talked about this. This is every single, 1 right, 2 right, 3 right, 4 right, all the way to 10 right, is everything except what? 0 right. So instead of doing all of these, what if we did this one and then subtracted it from 100? Because these will all add up to 100%. So instead of finding all of these, let's do no right, none right. Well, what will that look like? None right will be 10C0.
When you do 1 minus it, not minus.
This is going to be a decimal, so it's going to be 1 minus. And then 1/4 to the 0, and 3/4 to the 10th. If you did this and wrote it as a percentage, it's going to come out a decimal. But if you wrote it as a percentage, then you would subtract it from 100. This is 100%. So, answer to the question is, wow, 0.944. So again, what does that mean? I said wow, but we would expect this. that means you have a 94% chance of getting something right. If you guess 10 times, it makes sense that there's a 94% chance you get something right. Is that all right with everybody? Does it make sense to you that we did it that way? Yeah. Okay. Quit squeaking your chair. Okay. This next one. This is going to stress some of you out because it's full of letters, but I don't think I talked about this. Combinations, these are used a lot more than permutations. And so, this is a different notation, a notation that's used for combinations. So that means this. That's what that means. Nothing tricky, nothing new. So then this one means this. Okay, they're just combinations. So if you saw this, that would mean 7C3.
Oh.
Okay, now, we just talked about it a minute ago. Obviously, your calculator, that's not gonna be, it's not gonna be any good. So you have to remember what that means by hand. So we just did this. Let's do it with numbers first. What does it mean with numbers? What does this mean? 7 factorial over 3 factorial and not 2, 4 factorial. Now, let's do the same exact thing with with letters. So what will this equal? On top will be n factorial, and on the bottom will be r factorial and n minus r factorial. Okay? Yes, I let's look over here. This one is supposed to equal what? What does that equal? N factorial over n minus r factorial, and then these two subtracted. Okay, so remember, in a combination, so we had 10C4. That is this number over that number, and then their subtraction, right? That's your formula. So we have this number over that number over their subtraction.
Oh, like that.
Now, let's clean that up. What does this end up equaling? Just inside the parentheses, what does that end up equaling? What does that equal?
R.
Just R. Factorial.
Did you not? Not be negative. What the answer was?
N minus N plus R.
Oh, you're not.
You distribute the negative, not
Okay,
Oh, then you.
now what do you notice about the two sides of your equation? Aren't they equal? And that's exactly what you were supposed to show. Now, that is obvious if you think about it. what that is saying is that 10C3 is the same as 10C7. That's what this little problem is asking you to show. And I think that is very, very logical. This says there are 10 kids in the class. This is why I get frustrated. There are 10 kids in the class, and I'm going to take 3 of them out in the hallway. Okay, so I want you to think about that. Imagine there's 10 people in the room, and I choose 3 to be special and get to go to the hall. Now wait a minute. When I choose those 3 to go to the hall, what am I automatically doing? Choosing the other 7 to stay in the room. So if you have 10 people, choosing 3 is the same as choosing 7. Because when you choose 3, you unchoose 7. Does that make sense to you? And that will always be the case. Now, did you notice the symmetry in Pascal's triangle? So for example, here's the 5th row that we had on there. You notice the symmetry? Same on both sides. The one above this is 1, 4, 1, 4, 6, 4, 1, and then we have this one. Okay? Now, this is also symmetric. The whole thing, the whole triangle is symmetric, same on both sides. And the reason it's the same on both sides is this number is 5C4, this number is 5C1. They're always going to match. This number is 5C3, it's going to be the same as 5C2. They match. 5C0, 5C5. They match. So that's what you showed it here with letters, but it makes perfectly good sense. Does not work with P's, won't do anything like this with P's, but with C's that is true all the time. All right, so one more, B. Let's see if you can get B set up. What does this mean? What would that look like? Remember, it's the same as this. So on top will be n factorial. On the bottom will be 2 factorial and n minus 2 factorial. Now I'm going to add this. All right, so what does that one look like?
Plus 1 factorial.
N plus 1.
What are you doing over there? I know. Are we supposed to be looking at our watch? No. Oh no. Okay. So what's my numerator?
Plus 1. Or no,
N plus 1 factorial. What's my denominator? 2 factorial. And then n plus 1 minus 2 factorial. And believe it or not, all that is supposed to come out to equal n squared. Well, let's see if it does. What is n factorial?
More of the same thing.
What's 5 factorial? 5 times 4 times 3. Okay, so n factorial, we start with n
Subtract 1.
and then subtract 1. So n minus 1, subtract another 1 and
Go on
another 1
forever
and just keep
because-
going forever. Exactly.
So it's less than
So this is 2, and then that will start with n minus 2 And then n minus 3, we keep subtracting 1. All that's gonna cancel with all that. So the first fraction is n times n minus 1 over 2. That's the first fraction. All right, now I gotta do this one, but I'm gonna do the same thing. Let's simplify this first. What is this thing right here? Isn't that n minus 1 factorial? Okay, so on top, I have n plus 1, and you have a factorial, you start with your number, and then you do what you said, subtract 1. So it's gonna be n, and then n minus 1, n minus 2, and so on. And then on the bottom, I have my 2 again, and then start with n minus 1, and go down. The factorial. All of that will cancel with all of that. So the second part, the two fractions here added together. So that was the first part, this is the second part. Can I add, yep,
You get the n on its own.
you subtract 1. What's n plus 1 minus 1?
What happened to the first n plus 1 on the bottom?
There is an n plus
There's
1
not
on
one?
the bottom.
Okay.
There's an n plus 1 on the top.
Yeah.
That n plus 1 got subtracted by 2, so it became n minus 1. Huh? It's 2 factorial. What's 2 factorial? Okay, these 2 can actually be added because we have a common denominator. So we have n squared minus n plus n squared plus n. What does that equal? 2n squared divided by 2. What's 2n squared divided by 2?
Squared.
N squared. There you go.
Where's the ball?
So, that is something that if you have a question about and you have kept your eyes open, you can come into office hours and ask about.
Is that on quiz?
Huh?
Is this coming down quiz on Friday?
Jackson, I'm disappointed that you're asking me that question. I would expect that from the front row, not from you. However, think about all the quizzes that we have had this year. They have always matched the practice, right? Unless it's a bonus or something.
Yeah, Barbie. It should really be
It doesn't,
the middle fourth row right.
it doesn't hurt to once in a while stretch your brain a little bit, okay?
Get the brain up. How did the 2 factorial How did the two factorials turn into 2?
Factorial is 2 times 1.
Oh, it's 2 times. Okay. Hey Roy, what do we subtract the 1?
So on the top I have this, and on the bottom I have 2.
Okay.
They do.
So you just get rid of it? That's what it adds. I've always done this.
You don't ever just get rid of stuff, people.
Yeah, well.
We ended up with 2n squared on top over 2 canceled.
There's always a reason.
All right, 9-3, that
Oh my
one's due on, 9-2 is due on, Friday, but 9-3 we're starting right
I'm
now.
up and awake.
I'll be up.
Yeah, you're good, Jimmy.
One more time.
Okay.
So you decide. All right, 9.3, probability versus odds. Now, we have done some probability problems. We did one, the first thing we did today was probability question. But sometimes people use the word odds, and we need to make sure we understand the difference between the two.
Who is real next? Who is real?
All right, does anybody know, like, the mathematical definition of either one of these things? Because while people use them interchangeably, to the mathematician, they are not the same, okay? They have a different definition. Does anybody know the definition of either one? What do we mean by probability? Robin?
I know these are like the definitions, but isn't probability like percentage or something like of something happening and the odds is like compared like 1 in 5, like the odds are 1 in 5. Like
Well,
like
odds are usually expressed differently than probability, that's true. Probability is often expressed as a percentage. It doesn't have to be, it can be a decimal, it can be a fraction. Odds are generally expressed, like you said, as a ratio, like 1 to 5. But that is a fraction, that could be a percentage. So the way we express them is different. But what is the difference between a probability of 1/5 and odds of 1/5? What is the difference there? Does anyone know? Okay, what does the probability of 1/5 mean? If I say the probability of something happening is 1/5, what does that mean?
I mean, like if you do it 5 times, you get 1 for odds.
Exactly. Hang on to that thought, Jimmy. So probability is the number of successes
I know.
over the total. So Jimmy said, if I do something 5 times and I get what I want once, that probability is 1/5. So when you roll a die, your probability of getting a 2 is 1/6. Because there's 1, 2 on the die, and there's 6 total numbers on the die. Okay, now Jimmy, we're gonna add to that. That is exactly right. That's what
And then-
probability is.
So odds is like, I don't even know. Odds is more, I guess odds is like if you were to roll a dice, I guess. Like it's like options, maybe.
So if we say the odds are 1 to 5,
Means you can win once.
that means I win once and lose 5 times. This means I win 1 out of 5. This means I do it 6 times. I win once and lose 5. So sometimes you hear or see the expression even odds. Even odds means 1 to 1. What does that mean? The probability is 50%.
Yeah.
If you do it twice, you're gonna win 1 and lose 1. That means the odds are even. You have an equal chance of winning and losing. That means the probability is 1/2. Okay, so that's the difference. If you are given a probability, if we say the probability of your not having to take the exam is 3/10, then that means the odds of your not having to take the exam are what? 3 to 7. Because if the probability is 3 out of 10, that means you win 3 times out of 10 total. Well, if there's 10 total and you win 3, then you're gonna lose 7. So if we say the odds of me throwing him out of class are 2 to 3, then that means the probability of me throwing him out of class is what? 2 out of 5. 2 out of 5. Got the difference? See how they're connected? You can always go from one to the other. Okay? All right. Let's look at some problems. We are going to look at, over the next couple days, we're going to look at several kinds of probability. The first kind we're looking at is from a table, from what's called a probability distribution. So, read the question. Maggie and Elizabeth both have a bag of M&Ms. Both girls, being assumed mathematicians, dug their M&Ms out and organized them by color. Maggie notices that 30% of her M&Ms are green, 20% are yellow, and so on. Do you understand that chart? And Elizabeth does the same thing. These are called probability distributions. Now, A, if a candy is chosen from Elizabeth's bag, what is the probability it will be green? 0.3, right? 0.3. Oh, wait, that's Maggie. Elizabeth is 0.2, you're right, thank you. 0.2, I'm getting it out of Elizabeth's bag. 0.2? If a candy is chosen from Maggie's bag, what is the probability that it will not be yellow? 0.8. If there's a 20% chance of getting yellow, then there's an 80% chance of not getting yellow. Right? Now we're going to take one from each bag. What is the probability that we will be red and red? Important word. Red and red. Both red. Well, what is Maggie's red? 0.2. What is Elizabeth's red? 0.3. And I'm doing them together. It's like picking a jumper and a shirt. I'm going to multiply those. So the answer, no, it's not 0.6. Oh no, 0.06. 0.06. If you do not trust your arithmetic, then use your calculator. Right? You don't want to be messing that up. 0.2 times 0.3, 0.06. Still taking one from each bag. What's the probability that neither will be brown? So not brown and not brown. What's that going to be? 0.8 times 0.9. So 0.72. Neither brown. 0.72. One from each bag. First one, that's Maggie, is green, and the second one is blue. Okay, so Maggie green is 0.3, and Elizabeth blue is 0.2. So, 0.06. Chosen from each bag, what is the probability that one will be blue and one will be green? You getting the hang of this? Did you get 0.02? Did you get 0.02? Okay, you're not done. That's not quite right. Does anybody see the difference between problem E and F?
Yeah, this is second, first.
What's the difference
So,
between E
the
and
order
F?
is like one.
Yeah, here I had to be green and then blue, right? But here I have to be somebody's blue and somebody's green. So it certainly could be this, or what else could it be? Green and blue? There's no order there. So you have to consider both orders. You have to consider all the ways you could do it. You see that? So what's this? Green and blue, is that this one? Now, the probability of getting blue first is 0.02. The probability of getting green first is 0.06. It could be either one. So, what am I gonna do with those two numbers? Add them. I'm gonna add them. Total probability, I'm gonna add them. When do I multiply? When I am doing this and this. That's a multiply. When I'm doing this or this, I add. Always, in all the kinds of problems we do. All right. What are we waiting for? We're gonna go card problem. We're going to be dealt a 5-card hand from a standard deck. In order to do these problems, you have to have some familiarity with a standard deck of cards. So I've got a deck of cards up here. You're welcome to peruse it at your leisure. But you need to know the basics. Not the weird games, all that. No, not that. You just need to know what does the deck of cards look like. So step 1, there's 52 cards in a standard deck. Okay, do not talk to me about jokers. We are doing a regular deck of cards. Okay? Now, that deck of cards is divided into 2 colors, right? Red and black. And they're even, so it's 26 and 26. The reds are broken down into diamonds and hearts. So there's 13 and 13. Those are called suits. 13 diamonds, 13 hearts. Same thing on the black side. Spades and clubs. Within each suit, like the diamonds, there are 13 different cards. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1 is called the mace. It has 1 dot on it and 1 thing on it. Right? And then you have 3 cards that have faces on them. They're called face cards. The jack, the queen, and the king. That's what you need to know. If you don't know that, then you need to Google, sit down with a friend, borrow my deck of cards. You need to get that figured out. Okay? So here we go. Question number 1. How many 5-card hands are possible? So in other words, how many 5-card combinations are possible? 52, not divided by 52C5. That's how many hands are possible. That is a very large number. 52C5. That is the total number of 5-card hands that are possible. Now, when I read question number B, it says, what is the probability? Wait, stop right there. Probability is a fraction. What goes in the bottom of the fraction? The total, which is 52C5. That's your denominator. That great big giant number is the denominator. Because we need to know what's the total. 52C5. Now the numerator is what I want. What do I want? All diamonds. So the numerator would be 13C5. 52 total cards in the deck. Pick 5. 13 diamonds in the deck. Pick 5. So I can type that in on my calculator. Do not, these don't cancel. Factorials cancel. These do not. So don't do it, you just gotta type it in. So 13C5 divided by 52C5. And I got 4.952 times 10 to the negative 4. Now you are welcome to leave it that way, but remember what that means is this. It is a very small number. Do not bet your allowance on getting all diamonds, because you're probably not gonna get all diamonds. Okay, he said you could. Yes, you can. But the probability of it happening is very, very small. All right. Quickly, turn the page. I'm not going to do another problem. But I want you to look down all the problems on this page. All say, what's the probability? What's the probability? What's the probability? What's the denominator going to be for every single one of those problems? 52C5. If you're picking a 5-card hand, your denominator is going to be 52C5. No, but if you're talking about a 4-card hand, it's 52C4. Right? Yep.
I mean, I think I'm looking at it all.